In this video, we are to discuss models for time series. So we are talking about the different types of models in time series: the autoregressive model, the moving average model, and the mixed autoregressive moving average model. First, we'll start with the autoregressive model. Autoregressive. So, the autoregressive model, denoted as AR of order P. This of order P, this is how it is denoted. Is defined as, now we'll write the model xt, which is pi 0 plus summation of I ranging from 1 to p, pi I xt minus p plus pt. So this is the model for the autoregressive. This is the autoregressive model for time series. Now, this model we have here, we can write out the general form for this model. We'll also write it out. Well, after writing it out, we'll also define the parameters. Now, the general form of this model can be written as xt phi 1 x t minus 1 plus phi 2 x t minus 2 plus then continues plus phi I x t minus p plus pt. So we continue this way. This I, we can still write p here because this I ranging from 1 to p. So we can still write 5p here if you wish. So this is the general form of the model. Now, what are these parameters that are here? The xt is the time series value. This phi we see here, that is say phi 1, phi 2 to phi I. We call it parameter coefficient. They are the parameter coefficients. Also, we have our error term. The ET is known as the white noise. The white noise process, or you can call it error term. There's the white noise process, or you can call it the error term. So this is the autoregressive model. This is the general form. I've also defined the parameters. The parameters we have here, and these are xt. The xt is the time series values. Now, to take just some little example. For example, if you have auto regressive model of order 2, autoregressive of order 2. This is the model. Autoregressive model of order 2. We can write it as xt to be equal to phi 1 x t minus 1 plus phi 2 x t minus 2 plus pt. Also, we can also write our autoregressive model of order 3 model. write it as xt to be equal to phi 1 xt minus 1 plus phi 2 xt minus 2 plus phi 3 xt minus 3 plus our error 10 et. So this is how we can compute the autoregressive model of order P. The next thing to do is for we to write the other model. So we go for the moving average model. The moving average model. That one is of order Q, the moving average model. We move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. The moving average model is denoted as MA of order Q, and is as defined as xt to be equal to mu plus summation of j to be equal to 1 raised to the power of q, sorry, to q ranges from j equal to 1 to q, then theta j or theta q, because j ranges from 1 to q. Then we have x p minus q plus our error 10 plus our error 10. So this is the model. This is the model for the moving average. This is the moving average model. Let me write it out properly. The moving average of order Q model. So it's defined as this. Now, we can also write the general form. We can write the general form of this model. So we say general form. We can write the general form. For more on this topic, you need to subscribe to this channel. So our general form will give us xt to be equal to, now we have, this is our mean. If you wish, you can include it. It is our mean. If you wish, you can include it. So we have mu plus theta 1 x t minus 1 plus theta 2 x t minus 2 plus theta q x t minus q plus et. So this is the general form. Now, all we need to do is just to define the parameters we need. We define the parameters. How do we define the parameters? We move over to the other side of the ball to define the parameters. For more on this topic, you need to subscribe to this channel. So defining the parameters, we have our xt. Xt is the time series values. So we can also write phi 1, phi 2 to phi j or phi q are the parameter coefficients. They are the parameter coefficients. 3t is the white noise process or error term. White noise process or error term. So these are the things we need to know about this. For example, we might be asked to write the model for MA, moving average model of order 2. This two means order, the order, moving average model of order 2. So what do we do? The moving average model of order 2 can be written, we can borrow a leaf from this, can be written as this. So we have here, say, theta 1 x t minus 1 plus theta 2 x t minus 2 plus the mean plus, now we can write theta q x t minus q plus et. So this is how we can write the MA of order 2. Also, we can be asked to write MA of order 3. That means the moving average model of order 3. Moving average model of order 3. We can write it as xt to be equal to, this mean can also come first. The mean, we can also come first. Yes, so we have mu plus theta 1 x t minus 1 plus theta 2 x t minus 2 plus theta 3 x t minus 3 plus, we continue like this, plus we come here, we write q x t minus q plus et. So if you are asked to write the moving average model of order 3, this is how we can compute that. That's how we can write it. That is for that. The next, we move onto the mixed autoregressive moving average model. It's just the combination of the two different types of model. The third one is the combination of the two models we have just written, and it is called the mixed autoregressive moving average model. So for more on this topic, you need to subscribe to this channel. So it is called the mixed autoregressive moving average model. The mixed autoregressive moving average model is denoted as ARMA of order PQ The autoregressive moving average model, sorry, the autoregressive model is of order P, while the moving average model is of order Q. So we can write the model itself. So it's defined is is defined as theta times series pi plus, we now put down that of the autoregressive. We say summation of as I running from 1 to p, if you can remember, phi p or phi I, then x p minus p plus, because it is combined. This is for the autoregressive. Now we have summation of j running from 1 to q, theta k x t minus p plus e2 plus e2. So this is what we get if we want to write the model for the autoregressive moving average. So the ARMA model of order PQ is this. Now we have to write the general form so that we see how we can use this model. So we say the general form, we write it this other side of the board. So we have to clean this part to write the general form of this model. For more on this topic, you need to subscribe to this channel. So we have to put down the general form. The general form of the model can be written as xt to be equal to, this is our constant, plus, we say phi 1 xt minus 1 plus, it continues to give us summation of as I running from 1 to p, then phi p xt minus p plus, it continues, we now have theta 1 x p minus 1 for the moving average plus, it continues like that to give us summation of as j running from 1 to q, theta q x p minus q plus et. So this is the general form of this model. If you look at the autoregressive here comes first, while the moving average of order two comes second. That is how it is here. The autoregressive came first and the moving average came second. So what we just finished writing is the autoregressive moving average model of order PP. So it's a mixed model. It's mixed. Now we can be asked to write ARMA 2-3. That means autoregressive moving average model of order 2-3. We can do that. So we can do that say if we are asked to write ARMA of order 2, 3 model, we can be asked to write this model. What do we do? Very simple. We say ST is equal to autoregressive before we put first. Autoregressive. So we write lambda, which is our mean. Sorry, we have to define the parameters first. Let's define the parameters before we take that. Let's define the parameters. Now, the ST is our time series values. We have our phi 1 to phi p, which is parameter coefficient. Parameter coefficient for AR, that is autoregressive model. For AR model, also theta 1 to theta q are still the parameter coefficient for MA, the moving average model. We also have this ET. ET is the white noise, or you call it our error term. Error term, and lambda is the constant. Lambda is the constant. So we just take some examples to show how it is written, how the ARMA model is written. For me to do that, we move over to this side of the board to show that. For more on this topic, you need to subscribe to this channel. Now, how can we compute the ARMA model? For example, if we are given compute the ARMA model of order 2, 3. So what this simply means is that we have the autoregressive model of order 2 and the moving average model of order 3. So this is what we have. Now, how do we write it? First, our xt is equal to, we can write first the autoregressive model, which is phi 1 xt minus 1 plus phi 2 xt minus 2, which is this, the autoregressive, plus it continues, plus write summation of as I running from 1 to p, phi p xt minus p plus lambda, plus we continue with the moving average. The moving average will have theta 1 x t minus 1 plus theta 2 x t minus 2 plus theta 3 x t minus 3 plus it continues like that to give us summation of j running from 1 to q theta q then xt minus q. So this is how we can compute the ARMA model. This is how we can compute the ARMA model. But now, since this continues, see what we do. We now have to delete this part. Sorry. Since it's a combined model, see what we do. We have to delete that part. We just write lambda plus theta 1 xt minus 1 plus theta 2 xt minus 2 plus theta 3 xt minus 3 plus et. You are still correct. You are still correct. So this is how we write it. We can also be asked to write the ARMA model of order, this time 3 here, and this time let's say 2 here, model. So what this simply means is that we have the autoregressive model of order 3, and we have the moving average model of order 2. So we can still write it out. It will give us ft is equal to phi 1 xt minus 1 plus phi 2 xt minus 2 plus phi 3 xt minus 3. This is because we have it of order 3. That is why we stop at 3 plus our constant 10. Then we now continue with the moving average part. The moving average will now be theta 1 xt minus 1 this side, theta 2 xt minus 2. We have it of order 2, then plus our error thing. So this is how the autoregressive moving average model can be computed. This is how it can be computed in time series analysis. So for more on this topic, you need to subscribe to this channel to get more on what we have been doing.